Awesome. Thanks so much, Natalie. Thanks so much, everybody. Great to see you all. Thanks so much for joining us here on this beautiful Wednesday afternoon. At least here it's beautiful in Austin, Texas, so I can't speak for where you all are at. Hopefully, it's some great weather having there as well. All right, so we do these webinars periodically throughout the semester, throughout the year. A lot of these webinars focus on some of the different features that are available on DesignSafe. Some of these webinars are use cases. Some of them are actually talks given by some of the scientists who use DesignSafe. So today is going to be kind of a hands-on exercise on using DesignSafe for scientific computation. All right. So we do a lot of scientific computation here at TACC. You do a lot of scientific computation in your world. And I'm just going to introduce some of the Python tools that are available for you to use. All right. If you haven't been on DesignSafe in a while, check out DesignSafe. There's a really cool story about the hurricane simulations that are performed by our scientists on our system, what they do, how they do it, and what software systems they use. So if you hadn't had a chance to check that out, please check that out for us. Also, a really cool thing that probably applies to a lot of you all here. So we understand that there is no silver bullet to solve your problem. There is nothing, there is no magic box that you can just plug your problem into and get your results out. Even if there were a magic box, there's a lot of tweaking, there's a lot of modules, there's a lot of intricacies in your research, and we understand that. So DesignSafe has launched a new event. It's a new training event called Spark. It is stands for Strategic Program to Accelerate Researchers in Computing. The idea is sometime in July from 16th to 18th, you'll come here to TACC. You kind of have some one-on-one time to talk with some of the research scientists, some of the computational engineers that work here at TACC, and can understand your problem that you're facing, that you're having, or that you're trying to solve. We will give you some hands-on training. We'll give you some research support from DesignSafe experts, from SimCenter experts, from TACC experts to help you kind of understand what research tools are available and how these research tools can be applied to do your science and to help your science. And the cool part of it is throughout the next year, that researcher, scientist, whoever helped you out, will touch base with you to see how these applications are unfolding, to see how your research is coming along, and to see what else we can do to support you. So feel free, please hit us up and apply for this. Applications are currently on. Go to DesignSafe, and we'll actually go there as well. Click on the training and fill out an application for Spark. There is some travel support available as well that you can apply for, and hopefully we'll see you here at TACC this summer. And let me tell you, Austin is a great place to be in the summer if you don't mind the heat. Also, we have a feedback mechanism as well. There's a survey attached to these webinars. Please, here's a QR code for it. Please scan that with your phone. Take our survey. These surveys give us a great understanding on if these webinars are useful to you, what topics would be most useful to you, where would you like to see DesignSafe go, things like that. We use this data to try and get you better content to help better training events which are focused on your needs. So it's very important. It's very helpful if you can fill these fill these surveys out for us. Sorry, it's been kind of a long day for me. All right. So with that, let's get ourselves going and kind of tackle what we're here for. So let me introduce myself. My name is Charlie Day, for those of you who don't know. I am a member of a user services group here at the Texas Advanced Computing Center. I do a lot with training and professional development, and I help scientists like yourself integrate their research into TACC systems and understand how TACC systems can support you. That's kind of what I do on DesignSafe. I'm the training lead here. I have actually a master's degree in cybersecurity and a bachelor's degree in computer science with biology focus. I've had a lot of fun in my career, from working at, at third shift at a gas station to, working as a consultant for NASA Ames. So I've done it all. If there's anything I can help you with, feel free to reach out to me. I'm more than happy to collaborate with you. All right. So why are we doing this? So Python has become a very go-to language for a lot of people. And the reason is there's a lot of modules in Python that we can actually take advantage of on doing scientific coding. And I want to kind of give you a broad stroke on what some of those tools are and how some of those tools work. Like I said, this is going to be mostly a online or hands-on event. And the reason we're doing this is we've seen as developers, as researchers, as computational scientists and engineers here at TACC, we've seen Python just kind of blow up. And we've decided, you know what? Let's take what we know of Python, what we like about it, how it works, and give you guys a tutorial, a hands-on tutorial, how you can do your science on DesignSafe using Python. All right. So for those, by the way, since there are currently quite a few of us on here, let me see how many of us right now. There are close to 35 to 40 people on here. I think to make life a little easier to launch these events, for those of you who have an even birthday, meaning you're born on a even day of the week, all right? I'm born on the 18th, so I have an even birthday. I would like you all to go ahead and fire up your Jupyter notebooks now. And then in about 15, 20 minutes, we'll have the people with odd birthdays fire up their Jupyter notebooks. So to fire up a Jupyter notebook, we'll go to DesignSafe. Yeah, that's fine. Hopefully y'all can see my screen. So I'm going to designsafe-ci.org. I'm logged out right now. I'm actually logged in right now. I'm going to go and log out so you all can see exactly where I am. So I'm going to log out. So this should be the screen everybody sees. So those of you with even birthdays, click log in. Connecting to Tapas, you're all good to connect to Tapas. That is the TACC API system, and it's just telling you, hey, is it cool that we use this service to get your information? It is. So click connect. I've already logged in, so it's already got my information in there. For those of you who are logging in for the very first time, it's going to ask you for your TACC username. So the username that you got for your login, your password, and then it's going to ask for the TACC token. So that is when you got your MFA setting. So you go to your phone, get your TACC token and throw it in. So you should be able to get to this screen here. So now we want to launch your notebooks. Once again, this is only for those people with the even birthdays. The odd birthdays, you're going to be doing it here in about 10 minutes. Click on Use DesignSafe. Go down to Tools and Applications. And then under Analysis, and depending on how big your screen is, the things might show up a little differently. But under the Analysis, there is a Jupyter notebook. So we're going to click on Jupyter. Now, there are quite a few flavors of Jupyter that we have here at TACC, depending on what it is you're looking to do, what your needs are. There is a standard Jupyter Hub. There is the HPC version, so you can run some parallel code on Stampede 3. There's an HPC version that uses GPUs. And then there's a native version that has optional MPI support that also uses GPUs. So if you're looking to do some CUDA code, you can do your CUDA programming here, just regular high performance coding here. For our needs, we're just going to go ahead and run the standard version. I'm going to click on Get Started. Now I'm going to go ahead. So that'll take you to this screen. We're going to click Launch. Some of you, since I've already launched it, it's going to take me directly into the environment. For some of you, it might actually have another landing screen where you have to select which version of Jupyter Lab you need. The first version, I believe, is 2024. I think it's called Jupyter Hub or Jupyter Lab, one of the two. It's August 2024. That's the version you want. So go ahead and click on that and launch it, and it should come to the screen eventually. All right. For those of us who with odd birthdays, you hold on for another 5-10 minutes and you'll get ready to launch here soon. Okay, so we know that Python is a very popular language, and there's a reason behind it. It's because it's got something for everybody. It's got something for information technology guys. It's got something for our computational science guys. It's got raw computer science needs. If you're a DevOps guy, it's got utilities for you as well. If you're a researcher, it's got utilities, data analysis. Everything is here for you to use. So Python is great for that. Our job today is we want to introduce to you how to do some simple Python scientific coding. We want to solve something. All right, so we're going to solve something which most of us are familiar with. We're going to solve the heat equation. We're going to use that with a simple stencil that we can code up in Python. Along the way, we hope that you learn some basic Python syntax. I'm going to show you some really cool techniques so we can actually plot and visualize our data. And then we're seeing if we can figure out a way of maybe animating our data as well, since a lot of us have solving problems that change through time. Let's see if we can animate it. And then, of course, we need to save our data set as well. One thing we do a lot of, and honestly, I'm guilty of it as well, is we'll run some code. We will load up some variables and see what the results are. And we'll graph it and say, hey, this is awesome. And then we'll immediately start changing our variables, changing our constraints to get something new. Problem is, we should really save those data sets along the way. Most of us just throw those data sets away and we create new data sets and view it and keep doing it until we get a data set we like. The idea is we want to save those data sets. Why? Because we can learn from it. Even more importantly, we can teach an AI and train on those data sets, and therefore maybe being able to extrapolate new information from that data set. So the idea is let's keep it, let's not destroy it. So hopefully I'm going to teach you some ways of being able to keep your data set using Pandas data frames. Okay, so now everybody with an odd birthday, fire up your Jupyter notebooks. All right. So then everybody should be able to get set up again. Okay. So let's go ahead and fire it up. So while your Jupyter notebooks are firing up, let's go ahead and give you a little bit of background on what it is we're doing and how we're going to do it. So the heat equation, for those, especially for those of you who are brand new, I do know we have some students in here who may have not ever played with any PDEs. Let me give you guys a little quick rundown on what it is. So a heat equation is basically a partial differential equation. What does that mean? That means the equation that we're solving has a lot of variations to it, or dependencies on it. Let's put it that way. It's a lot of dependencies on it. So depending on how we're viewing the data, that equation might need a little might need to be solved with a different referral point, a different point of view. So that's really all it is we're going to solve this equation, which is du dt minus alpha del u equals 0. This is what we're solving. We can rewrite it so it looks a little bit normal in a Cartesian factor in this way. Du dt minus alpha d square u over dx plus d square u over dy equals 0. All right, so what does all that mean? Well, u, in this case, is a quantity that we're trying to solve for. That is what we want to know. All right, in our situation, it's the heat equation. So imagine we have a big giant solid bar, okay? And this is like, just to give you guys an idea. And at each corner of this bar, we're gonna have big blocks of ice. So that makes it really cold. In the middle of this bar, we're going to put a heat source. So it's going to be really hot in the middle and cold on the edges. Now, the idea is if we take that heat source away, or if we take the cold away, everything is going to approach some sort of steady state. So if we take the heat source away, our initial plot is going to look something like this, really hot in the middle, really cold in the center. And as time goes on, that temperature is going to slowly come down and go back to steady state, go back to, cold all the way across. The thing is, how do we figure that out? How can we analyze that? How can we predict it? So that is what we're looking for. U is going to be our temperature at any given point on that bar. T is our time. So as T moves, that temperature is coming down. Or the inverse problem, as T moves, that temperature goes up. One of the two. And then X and Y, those are just our spatial variables because we're solving it on a axis system. And so we want to, give X and Y values so we can plot it all out and find the solution for everywhere over time. We're going to do something slightly different. Instead of a bar, because bars are fun, but they're just kind of generic. Let's do a plate. So what we want to do is for our heat equation is we're going to create a grid. And we're going to solve a plate of information. So imagine all of the entire plate being 0 and saying one edge is going to be hot. And we're going to see how that heat transfers through that plate. Okay, so how are we going to do that? Well, we're going to introduce a finite difference method. And we're going to actually code this by hand. I do know that Python has quite a few finite difference method modules that you can load in, that you can use. There's a popular module called SciPy that actually has some solvers built into it. But we're going to go ahead and solve it using a template, using a stencil, using something like Euler's forward. That's going to be really relatively simple for us to code up, especially the amount of time we have to code it up in. So we're going to approximate it, and we're going to approximate it like this. We know that this is very oversimplified, that there are a lot of other terms in Taylor series expansion that we are just going to let go to 0 because those are going to be sufficiently small. But you should get a rough idea of how this method's going to work. So we're going to essentially we're going to remove the limits. So then instead of solving differential with the limit symbol, we're just going to use the delta symbol and make it a little bit easier for us to solve. And this is how we're going to solve it. We have f prime of a is approximately equal to f of a plus h being our step size, minus f of a all over h. So that is essentially what we're going to solve it with. And a couple other information. How do we do that? We're going to discretize our grid. So our domain is going to travel over x, y, and t. So this is what it kind of looks like. We have x, y, and t. Here's our access system. We're going to say that xi is equal to I times delta x, so how x is changing. Y sub j is equal to j times delta y. T sub k is going to be k times delta t. So essentially, we can say u x comma y comma t is going to equal to uk ij. So this is what we're solving and how we're solving it. All right. Finally, a little bit of other information that we need to know is we need to actually figure out how we're going to solve it. What are we going to solve? So yeah, here's some math. This is kind of what it looks like if we go through and put the heat equation in and, do some substitutions. We get this guy. I know this isn't a math class, so we're not really digging into the math too much, but we're going to apply this method. So we do need to know how it kind of works. But if we rearrange that equation, and just to make life easy, I'm going to say that our delta x and our delta y are going to be the same. That way it makes marching through the grid a little easier. So we're going to set delta x equal delta y, and then we get this final equation here. So we're going to solve use what we're solving for. It's the temperature at each one of those points on our grid. We're going to say uk plus 1 equals uk plus 1 of uij is going to equal gamma times uk at I plus 1j, uk at I minus 1j, uki comma j plus 1, j minus 1, minus 4 ukij plus ukij. All right, a lot of stuff there going on. Essentially, what this says is if I have this plate, I have this plate, all right? And if I want to solve a point in the middle here, let's say, to get that temperature, what I'm going to look at is I'm going to look at the previous time step. So this is the current time step. I'm going to look at the previous time step that was already calculated, and I'm going to look at all of the neighbors that are around there. Meaning, I'm going to look at the point above, the point below, the point to my left, the point to my right, and what the value was at the previous time step in the middle. So I'm taking all those neighbors of what I already calculated, and I'm going to use those to predict what the next point in the next time step is going to look like. All right. So once again, I'm going to use all the points from the previous time step, all the neighbors that I know of, and I'm going to use those to solve for the current time step. All right. So I'm going to use all these UKs to solve for UK plus 1. And then once I find out what that UK plus 1 is, the next time step, I'm going to use all those that I calculated and find the next one, and so on and so forth. All right. So hopefully everybody's still with me. Okay. All right. One last little bit, and then we get to do some coding. This is what things are going to look like. So here's our final, everything coming together. There's our plate. Whoops, one more. I didn't mean to skip that slide. There's a plate. I'm going to say this edge right here of my plate is going to be 100 degrees Celsius. And everywhere else is going to be 0. So everything else is going to be ice cold. So at t equals 0, everything is ice cold except that top edge, which is going to be at 100 degrees Celsius. Now for our model, just to make life easier, I'm going to take a delta x value of 1, an alpha value of 2, and see if we can code this Python code up. We're going to essentially solve this program numerically. We're going to see what the temperature is everywhere, denoted by I comma j, and seeing how that changes through time. That's denoted by k. All right, that's all the background information. We know everything we need to know to be able to solve this equation. So let's see what happens. Okay, modules we're going to be using is Matplotlib and NumPy and Pandas. All right, we'll talk about what Pandas is. That's our data analysis. The functions, we're going to need a function that calculates the value of u, and we're going to need a function that manages our plots, just to make life easier for us. Okay, so hopefully everybody has their Jupyter notebooks fired up. Everybody has this screen that they're looking at in front of them. And now everybody's sitting and wondering, what are we going to do next, Charlie? So what are we going to do next? Two things. Well, first off, I want you all to go to the terminal window. And this is just something that you're going to need to do. I already kind of did that in the beginning over in a notebook that I've already written. But I want to do a pip install. So you can all type this with me. -- user, and it is scikit-learn is what we're going to be installing. And if this is too small, let me make this bigger for you guys so you can see that. We're going to pip install -- user scikit-learn. Oh, by the way, one last thing I want you all to do is is when you first fly over here, you're going to see these folders on this side. Click on My Data. This is where all of your data kind of lives, all of your applications, all of your files. So you can see here, all of my apps live here. So in your My Data folder, that's where you want everything to go. All right, so we're going to do this pip install -- users.
Sorry, real quick. How did you get to that window? I got distracted. Sorry to be
Oh, no
obnoxious.
worries, no worries. So what I want to do here is I'm going to go back here to back plus. I'm going to click on a console window. So I'm going to click on,
Okay.
yeah. Um,
Which one? Okay.
so we have all, so when you land on a landing page is what we're
Yeah,
looking
I'm
at
there.
here. One of the things we will have here is these console windows. We also have a terminal window. So what I
Mhm.
want to do is I want you all to fire up a terminal. So click on here where it says terminal. That should take you, that should take you to this screen here. The other screen will work too, but this might be actually better in
Okay.
terminal
Yeah,
window.
thank you. Thank you.
Okay, great. So now in this terminal window where it says I have no name at Jupyter Charlie, okay, because this is just our console, I'm going to do the following. I'm going to do a pip install scikit learn, and I'm pretty sure I typed that right, and hit enter. For me, it's already satisfied. For you, it might actually start installing stuff. If you have an error, do this dash dash user. I don't think we need this anymore. Oops, one more time, dash dash user. To make sure that scikit-learn is installed. We might play with some scikit-learn stuff depending on how fast we go through all this stuff, but at least it will be there for us when we need it. Now, I'm going to create a new folder and create a new folder. Might help from actually hitting the wrong right button. New folder, and it should create this folder somewhere called Untitled. I'm going to give this guy a name. Whoops, double click that too soon. A new folder, and I'm going to give this thing scientific programming dash Python, just to give it a name so I can at least organize my stuff. All right, so now let's start up our Jupyter notebook. We're going to click on Python 3 under notebook. Once again, on that landing screen, if you click plus up here, the big blue button, it takes you to these landing screens. I'm going to click Python 3, and that gives me this notebook. If you notice, this notebook has no name. We can save it as something if we like as soon as we're ready for it. Python, Jupyter notebooks are actually really easy to manage. Uh, each one of these things is called a programming cell, and inside those cells, you can put a little bit of Python code. So if I say print, hello world, exclamation point, and then hit shift enter, it will execute that little bit of code for us. Now, the other thing we like about Jupyter notebooks is that they're also very pretty. You can make these things pretty to manage as well. So if I want to give this a title, I can switch my type of cell from code to markdown. So you see here where this drop down is. If I click on markdown, I can put some markdown, some titles in here. So I can say this is my first notebook, Jupyter notebook. Oops. Space. There we go. And it gives you a title. And we can also do like minor ones as well. So I can do 2 pound signs here and say, let's do some science. And so on and so forth, where you can do all these headers. If you Google Markdown formatting, it'll give you a great cheat sheet on how to do other things in Markdowns. You can do like actual equations using the different formats for that as well. You can put raw HTML in there. So if you want to actually write a research paper inside of a Jupyter notebook, you can do that. And there are actually some great examples on DesignSafe to show you how to do that as well. But for the most part, we use Jupyter Notebooks just to do our Python coding. We split it up into like logical bits as we're flowing through our code. So it's like very easy to read. All right, so the first thing we want to do, if we go back in here, we need some modules. So let's go ahead and import those modules. So I'm going to type import NumPy as NP. So NumPy is numerical Python. It gives us some information. Oh, wow, this is new. It gives us some information on how to do numerical methods and do math stuff. So NumPy, numerical Python, is one of the modules that we need. I'm also going to import in Matplotlib so we can do some graphs. Matplotlib, and I want this thing called pyplot, P-I-P-L-O-T. So it's matplotlib.pyplot, and I'm going to say as PLT. All the as function does is when I'm starting to use these modules later in my code, I don't have to type in matplotlib.pyplot over and over again. I could just type PLT. And I mentioned that I want to do some animation stuff. So I'm going to load that library as well. Matplotlib has a really cool animation library. So I'm going to pull that in and I'm going to call it animation and just animation. And also, I'm going to load one more thing. So from matplotlib.animation, I'm going to import in this thing called func animation. And oops, mation. There you go. Everything's typed right. Now I'm going to do Shift Enter to execute that little bit. So that imports all the modules I need and all the modules I want to use. So next thing, and I'm going to go ahead and, do something that all my computer science professors will love. I'm going to comment my code. All right, we need our variable list. Of those things, we need our variables. These are things like our plate length. How big is this plate going to be that I'm going to solve for? Max iteration time. Max iterations. We need that alpha. Remember, we need our delta X, etc. I'm sure we need other variables, but those are just the ones. Shift Enter. There's my bit. Tells me what the next line of my code's going to do. Set that up. I'm going to do one more thing too. I'm going to create a list called data records, and I'll tell you why. Remember, I mentioned that, we shouldn't throw our data away. We should keep it. So I'm going to hold it in something called data records. Then we also need our plate length. And I'm going to say plate length is going to be 50 units. So it's going to be 50 by 50. We also need our max iteration time. I think we'll need our max iteration time. Maybe not. All right. I'm trying to think ahead in here. Alpha, that little guy is going to be 2.0, we said. And our delta X is going to equal 1. All right, I'm going to hit Shift Enter again. If you notice, by the way, as we're hitting these Shift Enters, you see how these numbers are changing on the side? That number is our order of execution. So if I go back up here and I run this piece of code again, you'll see that execution is now 4. If I run it again, my execution order is now 5. So this is just telling me what order things were ran in. It becomes useful when you change variables and you want to run thing again. You want to make sure that the execution order reflects the new variables that you changed or values that you changed. Okay, the next thing we need is a place to store the stuff we're calculating. So let's go ahead and do that. Calculated variables. Things like delta t that we're going to calculate, gamma that we're going to calculate. Those are everything that we came in this screen. So these values that we need to kind of figure out what their how we're going to calculate them. So gamma is calculated by alpha delta t divided by delta x squared. So that's how we calculate gamma. Alpha, I think we already gave a value of like 2.0, so we know how to calculate that. Delta t, I figure where we're calculating delta t at. Did I give it a calculation or am I just going to throw it a value? Let's throw it a value just to see how things work. Okay, so those are the things we need, but etc. Because there are other things we might calculate later that I'm going to bring back in here. Shift Enter. Yeah, make that a little small. There All right, calculate variables and such. So here, delta t. So delta t is equal to that delta x squared. So if we had this value here, one more time. So you can kind of see what delta t's value is based off of alpha and dx squared. So we're going to go ahead and rewrite this so we can figure out what our delta t value is. I thought I had that calculated as well, but I must have cut that out of my slide deck. Anyways, my apologies. Whoops. But delta t is going to equal delta x squared. So here's my delta x is going to be delta x squared. And that's how you denote a square in Python, divided by 4 times alpha. So there's my delta t. The next thing I need is a gamma. And my gamma is going to equal that exact same equation we had on the slide deck, which is alpha times delta t that we just calculated over delta x squared divided by delta. I can type, right? Delta x squared. All right. So those are the only two things we're calculating at this point. Notice my execution order is 6. Things are still proceeding down. Okay, the next thing we need to do is we need to set up, set up our initial conditions. So set up initial conditions. Just like anything we start, there has to be a starting point. At time equals 0, what are our variables going to be? What are our values going to be? That's what we need to establish and tell the system, this is how we're going to start things. First off, we need this guy u, right? That's what we're calculating for. I'm going to set this up. So inside of numerical Python, NP empty, what that does is sets you up with an empty array. So we're going to create this array of u, and we're going to say it's going to be empty. So there aren't going to be any values in there. And we're just going to give you the definitions on what u needs to be, how big it needs to be, how many values, et cetera, et cetera. So we already know that ut is going to be u is going to be 3 dimensions. It's going to be based on time, x, and y, right? So we need to tell it how big those values are going to be. Well, we know they're going to be, well, the max number of iterations of time. That's u. And then, of course, we have plate length, comma, plate length. Plate length by plate length. So x, y, time. So there we go, set up with our number of u's. Now, every place inside of u initial, it's going to equal 0. Remember, everything is going to be cold. U top, that means the top level, remember, if we go here, up one, this top edge is going to be our hot edge, and everything else is going to be 0. Let's go ahead and define that top edge. UT top is going to be 100. U top is going to be 100. Don't need a semicolon. U left is equal to 0. U right is equal to 0. Now you might be asking, Charlie, why are we doing this? We just have that top edges, right? Yeah, but you know what? I might want to later write this code or solve this code where my left edge is going to be my hot edge, or my right edge is going to be my hot edge, or even someplace in the middle. So having these variables that define what those edges are is going to be kind of nice to have to fall back to. And then I'm going to type u.fill, u initial. Okay, what ufill does, oops, it didn't like something, np.empty, nt is a data type. Oops, sorry, my bad. Need double parentheses here. empty, and then it's a function, and it takes that as my variable there. There, much better. My bad. That's what happens when you live code. We make mistakes. Everybody makes mistakes. Just so you know that. Makes me feel better sometimes. All right. So double parentheses where I missed there. So what does this thing do? So line by line, this sets up a empty array of max iter by plate length by plate length. So if we can go back here, it's going to be max iterations is 50. So it's going to be 50 by 50 by 50. All right, that's what we set up over here. I can make my max iterations 200 if you like, and that changes things as well. But so now it's going to be 200 by 50 by 50. Initial value is going to be 0. The top is going to be 100, left is going to be right. These are just variables. These aren't doing anything. The only thing that did something is this one. This fills up this empty array with all zeros. And we can actually see that if we do a print, there is my array. It's going to give me some dots, but if you notice, everything is 0, which is perfect. That's exactly where we want it to look like. Okay, so things are working for us. Next thing we need to do is we need to set up our boundary conditions. Set up boundary conditions. Okay, so what are our boundary conditions going to do? Well, that's going to tell us what all the values are and actually set these initial conditions up into the actual array. So right now, if you notice when I printed that array out, everything was 0. So, it's like, but Charlie, we want the top to be 100. Well, we do, but we need to tell it to do that inside of U, and we'll do that here inside of the boundary conditions. First thing, arrays inside of Python are kind of cool. We can do a lot of cool stuff with them. So for example, we can say, hey, give me all of my elements. So just refer to U, or give me, all the values on the top, and then let's do other stuff. So if I wanted to set that top bit to be my hot, well, that would mean, first off, at all values of time, because I'm going to be doing this in 0, all I really do is say, all right, at plate length, -1 to everywhere. Now, what is this cryptic looking thing doing? Well, what this cryptic looking thing did, if I do that, it might help just a little bit. What this does is this tells me plate length -1. Well, plate length is 50. -1 is 49, right? So what this is saying, from 49, and I could say here, and I'm going to put in parentheses 50, by leaving it blank, it's saying start with 49, go all the way to 50, which is just that little bit. That is my top edge. Set that equal to U top. So that's going to be equal to 100. So if I want to say, look at the left edge, I would say U colon, comma, colon, 1. That means everything that from 0 to 1, or from that goes to 1, which would be that left edge, because that's where it starts at, 0 to 1. That is going to equal U left. This one. I can now also do, so we can do our right, which is going to be everything, comma, plate length, -1 to the end is equal to U right. GHT. All right. And finally, we need our bottom. So that means everything that goes to 1 there. And now, 1 colon. Top, bottom, yes, 1 colon is equal to U bottom. Shift enter. All right, everything still works. That's good to know. No syntax errors in there. So this established our boundaries. Going from U, plate length colon, plate length -1 colon the end. So that bit goes from 49 to 50. Everything here is going to be U top. Everything from 0 to 1 is going to be U left. Everything from plate length -1 to 50 is going to be U right, the right edge. And then everything else, 1 to 0, 1 to from the start is going to be my bottom. So this establishes my plate. Okay, one of the other things we said we needed is a function to calculate those values of U. All right, let's create a function that calculates those values of U. And making my programming teachers proud, we'll go comment that as well. And we'll call this our function to calculate U. Calculate. Yes, there we go. So we're going to calculate our value of U. All right, so I'm going to create a function. In Python, to create functions, we use the word def, D-E-F, to define our function. We're going to define, I'm going to just call this calculate. Calculate. Something, maybe I should choose something I can spell. U. All right, so we're going to pass in this entire array, U, into our function, and we're going to have it calculate all of our stuff out. All right, so this takes a bunch of for loops for k in range. So remember that first thing is time, and we're going to denote that with k. Goes from 0 to, let's see, max iter time. Max iter time. -1, comma 1. All right, so a little bit about what this code does. This is a for loop, and it goes from k. So is when we're going to loop with k, and it's going to go, we're going to say it belongs in a range, and it's going to start from 0, is going to go to max time -1 in steps of 1. Why -1? Because we're not going all the way to the boundary. The boundary conditions stay, and we're just using the boundary. So we're going to max iter time -1 in steps of 1, colon. Now, the way Python works is everything is indented. So anything that is part of that for loop, as part of this scope, will be indented to show that it's part of that for loop. All right, since we have time, x, and y, we're going to need to create a three-dimensional statement. So we're going to need 3 for loops. For I in range, it's also going to go from 0 to plate length -1 in steps of delta x. Because delta x and delta y are the same value, we're just going to use delta x in both cases. For j in range 0 to plate length oh, I spelled length wrong up here. Plate length -1 and steps of delta x as well. All right, now calculate u, k plus 1. We're solving. Remember, all we're going to do is this exact same bit we showed here. U, k plus 1 ij equals gamma uk, all this stuff. The joy of using a stencil, like what we're doing here in Python, it's exactly what we see here. We're going to copy that line by or character by character into our stencil. So uk plus 1, comma I, comma j is going to equal, and just we have more line, I'm going to put it underneath. It's going to equal gamma. Actually, you know what? Let's not do it that way. Gamma times, because I want to show you how this kind of grows as you type. U, and this is always the fun part, k, I plus 1, j. All right, plus u, k, I minus 1, j. Remember, we're filling in the stencil, which means we're using all the points from the previous iteration, grabbing those neighbors and putting it into our stencil here. U, j plus u, k, I, j minus 1. All right, there's j, I plus 1, I minus 1, j, oh, I'm sorry, this should have been I minus 1, j plus 1. J, k, I. Oh, right, this should be j plus 1. And now UKI j plus 1, and now we need UKI j minus 1. There we are. It's getting ahead of myself. I j minus 1. So I plus 1, I minus 1, j plus 1, j minus 1. Okay, now we're on track. Minus 4, that last little bit here, which is 4 minus ukij. So that's 4 times u, k, I, j. And that is all multiplied by, oh, plus this ukj. Oh, I already actually have that. Nope. Got my 4. 1, 2, 3, 4. What am I missing? UKI plus 1. All right. J plus UKI minus 1, J. U 1, 2, 3, 4, 5 terms. Okay, those are my 5 terms. I was losing track of what I'm doing here. U, A, so we just need a final term now. I, J. Shift, oh, enter. So that gives me all my UKIs. So this, like I said, it is exactly this line here. All of our terms plus UIJK. And finally, like I said, this calculates all of the values of U for us, right? And remember I said, let's not throw these values away, let's store them. So we're going to store these in a list. And remember that list we created up here called data records? That's what we're going to store it in. So Python has this thing called a list, data records dot append. So I'm going to go to each one of those and I'm going to append some data to it. And I'm going to append the data to this list, and I'm going to append it in a format that essentially will give us the variable that we want to save. So I'm going to say time, k, and then x, is going to be I. Y is going to be my J value. And then temperature is what we just calculated. Temperature is going to be that value we just calculated up here, UK plus 1, I comma J. So it's going to be UK plus 1, comma I, whoops, I comma J. Close that off, close my dictionary, close my function. So this is going to create a list of data for us, these data records. Well, a list of, it's going to save all my data points for me. So if we wanted to, we can do some fun stuff with it later. Come on. There we go. And that should end my function. And so I'm going to return. Since U is global here throughout my entire code, by passing the value of U in, I don't actually have to return anything because those calculations are already done. Shift enter, yay, just making sure. Shift enter is nice, can make sure my syntax is correct. So it looks like my syntax is right. We'll see what happens when we actually run the thing. All right, so now that's pretty much it. I can just do a calculate U, and that should run our code. Ooh, bug. Oh, plate length. Alien. Plate length. So might help if I correct that. There we go, plate length. Try that again. Shift enter. So I made my change here. I have to hit shift enter to commit that change. And now calculate U again. That time it did work. All right. Nothing exciting to see here. But you know what? We did save our data. Well, we actually can, I can just see, look at U. So if I just do a print U, should give me a bunch of values. They are changing. That's good to see that there are numbers there. But you know what? Let's look at, we did save stuff inside data records. Let's look at that too. Let me just do a print. Data records. Oops, what don't you like? Why is that? It's a weird error. Never had that before. Maybe because it's too long. Oh, data rate exceeded. That's really weird. If I do this, okay, we'll just put data records raw, and you can kind of see what everything looks like here at different values of time. So you can kind of see temperature. Here's our top edge. Here's that top edge from 1 all the way to 48, temperature is 25. And then every place else, it is 0. So that top edge is our hot edge. And we have data inside there. This is great. If we keep on moving through here, we should be able to see things that got calculated and everything's gotten saved. This is awesome. Okay, what can we do with that? Well, now that we printed out stuff and we verified that there's data in there, that there is actually data that we've calculated, let's figure out if there's a way that we can solve and run our data. Okay, so I'm seeing there's a lot of questions coming in here. I will tell you this, what my plan is going to be with this code is I'm going to actually put this into a GitHub repo. So then you all can grab this code from the GitHub repo. If there's anything that you need to look at, yeah, you can go ahead and ask me that question here and we'll run through there and I'll see what it looks like. It's a good idea to use a decimal when you're using a number that is not an integer. Yes, it actually very much is. Python doesn't care. You're absolutely right, Shia, that Pyr doesn't care. But us as coders, we kind of like to see, just by looking at the numbers, it's nice to be able to see what that number represents and where we're moving with it. Oh, you get a funky character when showing data records. Huh. Let's make sure our code is set up correctly. Like I said, I will share this code with you all.
Charlie, I think it's blank.
Or
It's
is it blank?
a null set. when I run data records. I don't have any syntax errors, but it's
Okay.
blank. I'm not
That is,
sure the return is on the right indentation because you have one return that ends all the loops.
Let me see. Let me see. Here we go. Um, so we are collecting it here. So, all right. So here is our guy that's doing everything. I am appending my data record as soon as I calculate this guy. And yes, my return is going to be part of that function. And my data records comes right underneath my UK plus one. So
Right.
as I am calculating UK plus one, I am appending my data record
Yeah,
immediately.
I typed exactly what you have. I get the null set.
Hmm.
So, oh, I didn't do the calculate.
Oh, okay. So yeah, I am now I call my calculate function that actually runs everything.
Sorry.
Um,
I
no,
was
that's
trying to
no,
catch
no,
up.
no no problem at all. Maybe I didn't
Makes
focus on that
makes
as
a big
well.
difference.
Yeah.
Thanks, Charlie. Sorry.
Oh,
Sorry,
no,
everyone.
don't worry about it. It's all good. I totally understand. Yeah, so once we have our function that calculates it, we do actually need to call the function to calculate our values. Once we do this, you should see everything populated.
Hey
With
Charlie, can you scroll right just a little bit on that cell? There's some text cut off in the calculate function.
Oh, yes. You know what? I'm gonna do this. Let's see if that helps. That got rid of the sidebar, so we don't do that. All right, so what we have here is UK plus one minus gamma or equals gamma times our function. And once again, this function is directly off the slide deck, but you can see what it looks like. It is UK I plus 1j. So that would be previous time step, uh, up one neighbor, UK minus 1j, down one neighbor, UKI j plus 1, that is left, I minus 1, right, and then the actual point from the previous value. And then we're just adding UKIJ to it. So yeah, we should have 1, 2, 3, 4, 5 terms, 4 neighbors plus the previous value. And then that entire bit plus 4 IKJ. And then right underneath that bit is that is where we're calling our data records dot append. And this data records is actually, I think, let's find out what that is. Calculate U, type data records. So data records is of type list. What's cool about Python, now this is one thing that Python is really, really good at, is it is good at collecting stuff. Whatever that stuff is, you can write Python to collect it. It could be a collection of integers, floats, texts, objects, whatever, or a collection of a combination of all that. So lists are kind of very powerful method for us to start analyzing data with. Like the first step of analyzing data is using a list or the list's big brother, which is a dictionary. So I'm storing everything in a list, and this is what it all kind of looks like just to verify that our list is correct. I know there's a lot of output here, so there's a lot of scrolling going on. What I am going to do is clear this output block off so we don't have to see that anymore. So let's clear that out. There we go. I just deleted it and then hit Shift Enter. Just to verify data records is of type list. What is U? U is a NumPy array. So now we have numbers in there, we have things in there, and they're all viewable. Of course, the big thing we want to do now is we want to plot it. Okay, we got the numbers, we got the data set, it's all great. Let's plot this thing. So the next thing I want to do is here, I'm going to go back, create another markdown, say, hey, 1, 2, 3, 4. Create a function. See, our function to plot our heat map. For any given time. So the idea here is you give me a value of time and I will return you a heat map plot. So heat map. And I also need, of course, what I'm going to calculate, which is all my U's versus K. First thing I want to do, so the way plots are designed, a plot in NumPy is kind of like a blank canvas. So when I say, hey, make me a new plot, what you essentially get is a blank canvas. And then what we have to do is manipulate that canvas for our graphs. So the first thing I'm going to do is I'm going to clear it, CLF, clear our field. Now I'm going to add a title because this will make, once again, my elementary school math teachers happy. If I'm going to make a graph, you got to make a title. Temperature at T equals, and this is going to be something we calculate from stuff coming in. So it's going to be K times my, remember, K is my time that's been discretized. So what I'm going to do is I'm going to tell you what the actual value is. So that's K times delta T. And I'm going to give it a format. So this is how you do a format in Python. So since this is, I'm creating a plot, I want it to be, give me 3 floating points after the decimal point. So this is what we're going to look at, delta T. So this is how I'm putting in that plot for T. And then I'm just going to say unit time. Since we don't really know, technically it's not seconds. You know, it's a unit of time that we've kind of normalized for our system here. So I'm just going to say unit time. Once again, keep our elementary school teachers happy. plt.xlabel. Remember, also got label our axes. X. plt.ylabel. We're going to call that y. And now we do a plt dot pcolor mesh. So we kind of have to tell it what kind of colors we want to add to this thing. There are lots of colors out there. I would suggest you just doing a Google on seeing what color maps are available. I'm just going to do the standard blue through, or blue for cold, red for hot. What am I going to plot? I'm going to plot UK, which is the array at any given time. And I'm going to tell it to use a color map. And the color map I'm using is plt.cm.jet. Like I said, there are other ones out there. I'm just using this one because I know that one off the top of my head. Vmin equals 0. Vmax equals 100 because our temperature only goes from 0 to 100. So that's our minimum value. That's our maximum value to feed into our color map. And the last thing that we want to do is we want to add in a color bar. So here is our function. Plot heat map for any given time. So that's why we're passing in our array and we're passing in which time we want to plot. Now, clear the screen, add a title, add some labels, tell it how we want the colors to be done, what it is we're plotting, and what our maximum min values are going to be, and what that color map looks like. So I pulled cm.jet just because I know that off the top of my head. And then give it a color bar based on this color map. And then the final thing we need to do is we've created this thing called PLT. We just need to return that. So return PLT. Shift enter. Okay, that worked too. All right, let's test this, make sure it works. I'm going to say PLT plot equals plot heat map. And let's pass it U20. That's going to be the K value that I want to send it. And I'm going to send it 20 of them. I'm going to at time 20. Remember, it takes a U at K and that K. So this is going to send U at 20 and temperature 20. These are going to be equal, obviously. And then I'm going to do a plt.show so we can actually see this guy. Woohoo, it worked. Yes. So let's look at time 1. All right, so there's our heat bar up here. Remember, so here's our color map. Here's our heat bar, and that's at time 1. What's it look like at time 0? That's at time 0. Whoops, this needs to be 0 as well. Oh, hey, this isn't calculating. Why aren't you calculating? K times delta T. Oh, oops. I need to tell it that it's formatted print. So this is what the F does. The F means that, hey, this is going to be formatted. There's a format in there you need to look at. Let's try that again now. Shift enter because I updated it. Try that again. Now it's changing. So at 1, it's calculations. At 2, awesome. 30, cool. 50, whoops, 50 is out of bounds. 49 is the size we go. There we go. Neato. All right, so let's see if we can animate this. So we have all these plot heat maps, right? And I could put in any number I want. So we can calculate that from 0 to 49 and just put them all together. Or what we can do, and we can save each one of these images and make like a flip book, which is something you can do. But I want to introduce you to something new that I came across a couple of years ago playing with these things. Matplotlib has this thing called Func Animate. What that does, or Func Animation, what that does is you pass it a canvas that you want to draw on. You pass it a function that you want it to calculate at each frame, and then you tell it how many frames you want. And pretty much it will then create a GIF image of your animation. So let's play with that. I'm going to do this. Def animate. So remember I said it needs a function to control your animation. So def animate is going to be a function of time. It's okay. All this really does is it's going to call that plot heat map. Yes, I know I can do this probably a lot easier just calling plot heat map directly. But you know, this is a tutorial just so you can see how things work. Broken down like this, it might be a little bit easier to read. All animate K does is it's going to call up heat map and pass it the value that I want to calculate. Now, animation is equal to animation. Remember, animation was this that we pulled in from matplot.animation called animation. So I'm going to say animation dot func animation. So that's the function I'm going to use. We're going to give it a blank plot plt.figure. I need to give it the function that controls my animate, which is my animation, which is animate, this function right up here. I'm going to now give it an interval. Well, remember the interval is essentially what is my delta value? It's going to be 1. Interval at every time step. And now I need to tell it how many frames I have. Well, the amount of frames I have is our max iter time. I already calculated that out there. We're going to have, 50 time steps. And then the bit is I don't want this to repeat. So repeat equals false. All right, so there is our animation function call. So all we do to make this animation function work is you define a function that controls your animation based on a single integer. So this is why I rewrote this function. It already knows that I want this amount of frames, max iter time. That's how many frames I want. So what it's going to do is it's going to call this animate function that many times. And it's going to pass in the frame as an int. So it's going to be frame equals 1, frame equals 2, frame equals 3, and so on and so forth to this animate function. and it's going to put everything into this plot figure. Okay, let's see if we did things right. So now the last thing I need to do is save this animation that we just created, or else we're not going to be able to see it. .save. And I'm going to call this heat equation animation .gif. Shift enter. All right, so you will get this because we're running this on our Jupyter notebook in a cloud environment, and we're not running this on our local machine. You're going to get this error where it says FFmpeg unavailable using Pillow instead. That's okay. If you're to run this on your local machine with a graphics processor or a graphics card and all that other stuff, this error would not be coming up. But it goes ahead and finishes, it runs, it gave me my number. It gives you what the last plot looks like, just so you know it ran. But if we go back to our file bit here, we should see an animation GIF. So if I make this a little small, bigger over here, heat equation animation.gif. That is the file we just created. If I double click on it, it gives us this little bit. So now we can animate this heat equation and how it's moving. Might have a little typo in there somewhere, which is why it's giving me those two heat layers from where our boundary conditions are. I probably changed something I shouldn't have when I was playing with this, but that's okay. We're still getting everything filled. We're getting most of everything set up. You bottom, you type, you left. I must have something in there sitting somewhere, which is why we're getting this reflection. But okay, so the heat equation's in there. We have about 10 minutes here. Remember, we have that thing called our data. You remember, and I was telling you how important it is that our data, we don't lose that. So we have this thing called data records. And data records is essentially all the data and all the stuff that we've created. What'd be nice is if we can take this data and save it as a, let's say, a comma delimited file, as a CSV. So remember I said what the other bit that we're going to import in is this thing called Pandas. So what Pandas allows us to do is do some data analysis. So I'm going to go ahead and import Pandas now, just to show you how simple it is to make this record into a CSV file. So the heart of Pandas is this thing called a data frame. All a data frame really is a data table, right? So I can say pd.dataframe. I'm going to call it a variable name. I'm going to call it df. pd.dataframe. I'm going to set that equal to, or just pass it in there, data records. This is that list we just created. This list up here is called data records. And I'm going to load that into a Panda data frame called df. And this is all I write. Okay. I can do something now. df dot.
Sorry, Charlie, do you mind backing up there? The data records, did you have to print or define that above? Sorry, I missed that because I had trouble with the animation.
Oh, no problem. So
No, good.
yeah, way up here, we established
Okay,
data.
it's already defined. Okay,
Yeah,
I
we
got
define it as empty. Now you can do this anywhere, but I define this data records as a blank list. So that's why you have the two
Okay.
square brackets that designates it as a list.
Yeah, thank you.
Yeah, and then all I did was I just filled data records up in my calculate U just to give it some stuff. So data
Right.
record dot append, and then I'm appending
Okay,
it in this format here. So
I
this
got it.
format is how we're saying time k, x, I, y, y, j, temperature uk plus 1, I comma j. And so now we have this data record that's got all of the data inside there in this nice little format. So what I can do now is I can save that as a data frame. So now I loaded it in as df, and now you can see what data frame did is it created a table for me of what, 117,000 rows, right? And I have time, I have an X value, I have a Y value, and I have a temperature. And so now what we can do with that data frame is we can save that as a CSV file, but what also it does is it gives us some simple data analysis. So I can do a df.describe. What that now tells me is it returns how many elements I have in my table. So I have 117,649. Same here, just put in a scientific notation because we ran out of space. It tells me what the mean value is. It tells me what the standard deviation is. The min value, the 25% of max, 50% of max, 75% of max, and then what the max value is itself. So it gives you some really good information about your data. You can also, when you're loading in a data, I always just have people, when you're loading in your data set, especially if it's a data set you've never played with before or looked at before, do a df, pull it into a Panda data frame and do a df.describe. Get this information out to you so you can see, does anything look weird? Does anything look off? For example, if I knew that my minimum temperature is 0 and it said that my minimum temperature is some big negative number, then I know that there's something wrong with this data set. And so I can do a little bit more investigating. But here, since I calculated myself, we know the data is clean, everything looks good. And so now to save this, I can do a df dot to CSV, and I can give it a name. I'm going to call it heat equation results .csv. And what that does is that now that creates a comma delimited file for me that is in table format with headers and everything. So if I wanted to export this now to a database, Redis, SQL, whatever, I have the means to do that. If I want to create a data store or a data warehouse off this heat equation, I could do that. If I want to take my heat equation code and I want to do some machine learning, now I have everything in this table format. And if I wanted to, I can load this into a machine learning algorithm that can now extrapolate some information from the data that I didn't realize. Let's go in the half steps that we're missing. What is the temperature type there? If you notice, we don't run this thing all the way to the end where everything's hot, right? We only are running this for 50 time steps because, well, we don't have time. I could write a machine learning algorithm based on this, train the model, and then see how far it goes out. And in fact, I might have that here somewhere when I was playing with this stuff before. Is it here? Maybe. No, this is one we just created. I have been playing with the it might be in a different project. Let's see. There we go. Yeah, this one. We can now, this is me playing with a couple of their other codes where I was doing the exact same thing. I can't find my machine learning bit. But I would like to explain a couple things I'd like to do. Is there will be a part 2 to this introduction to scientific Python programming, where we'll teach you some of the more advanced techniques of using machine learning and how you can feed this model in to make something bigger. I will also, I'll share the code with you where you can put this into a Python and use sklearn and use a linear regression to estimate what the next time step's going to be. Then we can verify our calculated versus our guesstimate and see how well our error is. But I'm hoping that this kind of showed you some of the Python tools that are available for you to do your numerical analysis work, to do your computational engineering work. So I will make this code available to you as well. We'll also make this videos available to you. One thing I would like to kind of show. I know we're running out of time here, but if you go to designsafeci.org Learning Center training, this is our training archive. This is where all of the previous webinars are held at. And you'll see this video from this class loaded there as well. We'll also on Slack post the repo for my slide deck, as well as the sample code that we created and the machine learning code to be able to do a linear regression on the model we created today. With that, we do appreciate your feedback. So here's that QR code again.
Can I
And
add one thing, Charlie, before you
yeah,
go? So
sure, Scott.
in the past, last year, Krishna Kumar and I did a follow-up to Charlie's
Yeah.
great webinar here to show how to speed up some of the calculations. Python can be a little bit slow and inefficient. And so I'm going to put in the chat a link to some resources that we have available for that.
Fantastic.
It shows how to use vectorization and numba and some other things that if you did want to take this simulation out to a long time until it was all uniform, it would take a long time using the loops, right? So you could do it in ways that are up to, I don't remember how much speed up we got, but like sometimes it's significant, like thousands of times faster. Yeah. So I put that in the chat. If you're interested in having that webinar again, let me know. I think that we've decided kind of not to do it this year to focus on a machine learning one, like Charlie mentioned. But if there's demand for it, we can always do it again.
Yeah. Well, just so you know, Scott, there's a part 2 that I created last night for the one we just did, which does use machine learning to estimate what the temperature values are.
Yeah, that's cool.
Yeah. Like I said, I was tired. I was tired, but I was antsy and I wanted to get something. I wanted to code something. So I did that little bit. So anyways, hey, everybody, thanks so much for your attention. Thanks so much for your time. I hope this was useful information to you all. Please feel free to reach out to us if you have any questions or if you have any comments. Feel free to reach out. You can find us on Slack. You can message me on Slack as well, or email me. Once again, thank you everybody for your attention. I hope you have a great afternoon, and we'll see you all next time.
Charlie, before you go, can I ask you a quick?
Oh yeah, please feel free if there's any
Go back
questions.
up to we had the def plot heat map. I'm frustrated. I get zeros all the way through time. Something's not quite right.
Okay.
If you just go up a few lines, I just gotta go up to where you had the plot heat map.
Okay.
And then plot show.
Sorry, wrong
No,
code.
it's above that.
Yeah, let me this code. There we go. All right. How far up?
Where the animation starts.
Oh, okay.
Something's not right in my code here. I'm just a little bit frustrated here. So,
okay.
Oh, you had 49 there. I don't know.
Oh, this was just to see, just
no, that's okay. I'm just getting blanks all the way through. It's like it's not, it's staying cold.
Okay. Let me go ahead. I wonder if we can have you share your screen, and then see if we can help you debug. If anybody else would like to stick around, feel free to stick around and I can help you all out as well.
We're getting some questions about part 2, Charlie. Do you have a time frame in mind for when you want to do that one?
It's up to you, Scott. I can do it. If you want me to do it in a couple of weeks, I can, if you have something already planned out, but we can get that on the schedule.
We do have one next week, so maybe we can wait until April, maybe a month now or something like that. We can chat about it.
Yeah.
And I can help you get together a Jupyter book, which is what Krishna and I made for ours.
Okay.
That'd be really cool to have one that goes with that. So, yeah.
Yeah, sure. I think as I coded it last night, I just can't find where I put it on here. So, all right.
Well, Jim, do you want to share your screen or?
Yeah, I put in a request. I don't know if
it my share.
Through. Yeah.
And you should be able to
ignore the clutter in the back. I'm more of a MATLAB person. That's the reason I ask a question. So something's not being calculated right here.
All right.
I may have a mistake here. Let's see, delta K, format, unit time. Is there supposed to be a comma here or something?
Let's see.
That's just in the title.
You know what?
I
think the thing that we're missing is we're never actually we're passing in U. So let's what happened?
case right here.
The
Our section.
format in the temperature.
Yeah. Let me do this. So I'm just trying to see your screen so I can see what we're looking at here.
I was trying to type and take notes at the same time.
Yeah, I
That's-
understand that can get frustrating. So we calculated U.
You almost need two computers to do this, right?
Or an assistant.
Well, unfortunately, my 50-plus-year-old eyesight's not what it used to be. So
In a second part, you write the letter F in the plot's title.
yeah.
You add that F, but I don't know if that's the.
Okay. One more thing. Can we do? Can I see your calculate U as well? So if you go up to the next, go up a little bit. Yeah. Function to calculate U, UK plus 1 IT. And does
I didn't see any problem here.
does gamma have a value? Can you move up a little bit? Move up to, yeah, here we go. Yeah, gamma's got a value. T's got a value.
Where's gamma here? Where the hell
Yeah,
is
gamma's
gamma?
there under calculate variables.
Let's see, alpha's defined, delta t's defined.
Okay, so I'm pretty sure that's all good. All right.
No, let's see, delta t, yeah, delta t is defined, delta x is defined, that's all good.
Yeah. That's looking good. So let's top, right, left. Okay, that's all good. Calculating U. U is going from
No, those are all okay.
yeah.
It's a bug someplace.
Actually, you know what? Do me a favor here. After you do the calculate U, just print out the value U on the next line.
How can I generate, oh, just hit return and just say print?
Yeah,
U?
just print, print U. That's fine. In parentheses. There you go. All right, so let's scroll down. Let's see what things look like. Yeah, see, it's 0 all the way across, even at the bottom where it shouldn't be. So something's going on with that calculate U function. So
Something
let's see.
right here.
Yeah, so we have UK minus 1 or UK plus 1.
Let me do this here.
J.
Yeah, gamma's not 0.
Yeah, UKIJ.
Let me check the boundary conditions here. If the boundary conditions are all 0, then it makes sense, right? So U top is 100, U left is 0, you're right. Yeah, it had the 100 in there.
Yeah. Oh,
I think this is the right range, right? I defined these correctly, or because I didn't quite study this, but the plate
yeah,
went into the
going
end.
from 0 to plate length, all the way across for your left and for your bottom and right. Yeah. UKIJ equals gamma times.
Oh, Charlie, is this the problem here? Is this in the wrong order? I don't know the syntax yet.
No, you're good. So what the colon does is like essentially saying start value, end value. So colon blank to 1 is going to be essentially 0 to 1. So it's going to be that left side. Where plate length minus 1 colon is going to go from there to plate length. So it's going to be 0 on that side. So that's all right. Where to start, where to end at. What is going on with this plate length code though? Something here. It's max iter times 0 for I range 0 to plate length minus 1 delta x, 0 to plate length minus 1 delta x as well. All right. UK plus 1. J plus 1. Okay, J.
One says plate and the other says must be say play. Plate and
Pardon me?
You're in the definition of calculate, the third row it says plate and your code It says play
Oh,
length
oh,
right there.
oh,
Right.
yes, that would.
That's correct. In the next row, in your code, you write play length -1.
Oh yeah, yeah. That was a on my, that was a typo on mine that we did catch.
Okay.
Yeah, it should be plate length. Because yeah, I had a typo.
Okay. Sorry.
Oh
But
no,
should I play, I'm okay, or should I take -1 out?
no, you're good. It should be plate length -1. 0 to plate length -1 delta x. What y is so
I
shift
don't see
enter.
anything wrong with the
Give me a shift.
brackets here.
Yeah. So let's commit that with shift enter. Because that does look correct to me.
Yeah, I found an error before I corrected some syntax, but
Yeah.
-4 UK, and it opens and closes the parentheses here. Well, just give me syntax error if that was an issue.
Yeah. Your
So now
code,
it's not,
I mean, your code looks identical to mine so
I
far.
know.
Um,
And that's right underlined
why
under
is that?
that.
Because when I just print out U for me, let me see.
All these damn brackets, I'd say, but there's 100 here, which I assume is what the top surface here. But it's not doing any calculations.
No,
So
it sure
somehow
is. It's like,
K is not in the right range. It's like it's going from 0 to 0 with maximum iteration time. Let's see what I have for maximum iteration time, 50.
yeah. Oh, and you're doing a plate length of 200, so that's fine. Hmm.
Let me do one other thing here. I don't trust anything here. You never know. Just make sure
Yeah.
it's defined. 49, so it's got a number.
Mm-hmm.
Does it keep the last value of K? If I say print K?
Uh,
I guess-
unless you
no.
run it, no, because K is outside of its scope, so it doesn't know what K is.
Yeah.
K is only in that scope. Um, so
Well, if there was syntax error, it'd say it's undefined, right?
right, correct. UKI plus 1J. And if we just print out U, so hit shift enter again. I guess you already did that. So shift enter is calculating. On that next line where it says type U, instead of doing type U, do a in this line over here. Yeah. Yeah. So in this line, do a just print, or just do U by itself on that line.
Just print U. Well, you want me to
Yeah.
replace that with print
Just,
U?
just type the letter U on a line by itself, not even print, just U. It'll give us a summary of what U looks like. Shift enter. And let's do a little scrolling here. So that's, yeah.
Hey,
That is
Charlie,
not,
does yours have the square brackets the same as Jim's? He's got, like on the left side, U, and then the K plus 1, I, and
Yeah.
J all
And that's
inside the
exactly
same
what I have.
square bracket.
yeah.
On the right side, they're separated.
Vector.
Yeah, yeah. And that's fine. That format's great.
That's all
Kind of
vector.
it helps us redefine how things look.
Somehow it's not advancing in time. It's taking the initial thing and it's like it's not advancing K.
Yeah.
Or gamma is taken to be 0 here.
Hmm.
I don't know what's going on here.
Why is calculate U failing? 0, 0, 0. I know it's something small, and I'm betting you money as soon as we see it, it's like, oh, there we go. UK plus 1 minus it's equals minus gamma.
There's not a spacer before that plus, but I don't think it makes a difference because the blue plus sign means it's realizing it's there.
Do what we see here.
It just doesn't like it.
Let's go back. UK plus 1 IJ gamma times UK I plus 1 J plate length minus 1, 0 to plate length minus 1, 0 to plate length minus 1, IJ. Parentheses end. We already know max iter time is 50. That's already been calculated. We're passing in U. We're calculating U.
About this.
Should be 49, says a value there. Plate length has got a value. Delta X has a value. UK plus 1 IJ equals gamma times UK plus 1. So what is wrong with it?
Charlie, quick question. When you type U, is that, yeah, I'm not used to saying, is this all the way through time? Just U?
Yeah, this
Or-
is
I want to get it for the first, is the K start with 0?
yes, K starts with 0. And goes to 49.
I don't know if this will work, Charlie. I just want to get the complete initial conditions here.
Okay.
No, it doesn't like that.
Oh, what you want to do there is just do a print use 0. Just pass in a 0.
U and then put 0 there?
Yeah. Yeah. So that's like K equal to 0. Oh, in square brackets, I believe is where you want it.
K equals 0 or just put 0?
0. Hang on 1 second. Let me double check here something else.
Oh, I think I have to put this in parentheses.
Yes, parentheses 0. Yeah, there you go. Shift enter. Yeah. That should be.
So I mean, it's missing my information, but I'd like to know if the top or the left boundary is all 100 or the top boundary. And you can't tell from this because all the data is not shown.
Right.
How can I get the coordinates and the value of the heat associated with that? It's like a digital map.
Right. Let me try something else here. Print U0. Whoops, not that. Print U. So we want to look at colon 49. All right, so I just want to double check something. So what you want to do is there, when you're doing that print U0, do a U. Let me put my marker back. So right there, do U open square bracket, colon, because so we want all time. And now for our X, we want, actually just give it X 40. So yeah, comma 49. So that's just going to be the 49 and then colon again. See what we have there.
Comma or colon or,
Colon.
oh, okay.
Yeah. So then close bracket and then close parenthesis and hit and shift enter. All right. So obviously, yeah, these should all be 100s. These should all be 100s instead of
So I
just.
don't understand what it's showing here though. So what do we do here? U is for all time.
Yeah, so
The
so
first
it
colon
is,
for all.
we have U, K, comma, I, comma, J, I think is how we have it.
I is in the X direction. I think J is in the Y direction.
Yes, so we have K, we want all values of K, all right? Then we want just the
Top boundary.
I equals 49, and then just all values of J is what we have here. Because I just want to
Right.
build a random bit to see what it looks like. And in my random bit, these values are all 100, where in your random bit, those are all zeros. So
Well, that's still odd though, because
yeah,
this is for all time or just, so these should be changing. This would be the initial
yeah, that's
conditions.
why we have this colon. Now, if you put a particular time in there, let's say time 0, so you can replace that colon with a 0, we should just get that one bit. See, if I do that on mine, I get all 100s. So,
Yeah, see, it never changes. That's the problem. See,
okay, so
so something's wrong in this equation here.
or something's wrong with things up here. Let's
Well,
see. So let me see what I have. You have colon, comma, plate length -1, U top, colon, everything is U left, colon, colon, colon 1, plate length, all of them U bottom. Yeah, and that's that. If you put a U in front of that, that'll print out all the values of U.
like that. Oh, it'd be nice if I told it what to do, huh?
Yeah.
Oh, sorry.
No worries. You're fine. You're great. So in front of the square bracket, put a U. So you want to do
Darn it, my
parenthesis
insert thing. This
U.
Python on my keyboard don't agree.
Okay. It's probably not helping that I'm putting chicken scratches all over your screen. We need, okay, so there we go. So I am, scroll back up if you could. Do a print U, plate length is, this should be 49. So print U49.
For the second or for the second argument?
For the second. Yeah, just hit shift enter there. Wow,
Not doing anything.
it's calculated.
Oh,
There
there
we
we
go.
go.
It calculated that for some reason. So now I got it. See, I'm gonna do it my side as well. And I do U, if I print U, you have colon, comma, 49, comma, colon. Square parenthesis. Yeah, see, I'm getting very different values. So let's
I
see.
mean, the first colon is that beginning of time, everything. I mean, is this
Yeah.
this is
Yeah.
wait.
So it is definitely something going on here. So now,
No, but Charlie, just real quick question that because in MATLAB's a little bit different. This is through the whole array, but this is time right here, right? And
yes,
that's
that's
all been
okay.
initialized to 0. So that should all be zeros. This is at is I in the vertical or horizontal direction? I don't recall.
I is our Y, or I'm sorry, I is our X.
I is in the horizontal direction.
Yeah, I
So
is,
this should be at the right-hand side, right? This is right-hand side of the plate, and then this is, again, this is everything here. Yes,
Yes,
it's
that's
all,
everything. That's everything again. So if we
this is
wanted
all on the right edge. This should all be along the right edge then, right?
let's see, this is,
Doesn't make sense.
all right, we have this.
Oh, yeah.
Up here is 0. Here is 49 for X.
Is there a
Is there a
problem with the
problem?
right edge code with those
Y.
Is
colons?
there a problem right here?
Yeah, I think
Yeah,
so.
that's what I'm looking at. So I think,
Again, I don't know the syntax, but
oh, this colon.
yes,
Yeah,
shouldn't be.
there should be a comma here.
Sorry, let me.
So let me clear out my chicken scratches here.
There
Clear.
should be a comma there.
Yeah, so we should have plate length.
Now it gave me a syntax error.
All right. So we should have colon for you, right? Should be colon, plate length -1, and yeah,
And
so
that's it,
this
right?
this colon is the issue. There we go. I found it. Dang.
Yeah, that's what I thought. It looked
Yeah,
odd.
so
Again, I
that
don't,
colon's gone, and then just and get rid of this comma here.
darn it. Sorry, what else to do there?
To get rid of this comma.
Get rid of it. Sorry.
So you should have there we go. Now we got some initial, now we got our boundary conditions. And now rerun the calculate. You have to refill it.
Where do I rerun the calculator? I
So
gotta
go back
actually
up
put that line.
one more just to double check, make sure our calculate function is good. So go to the cell above that. Oh, actually, we got time now. That's all right. So now essentially rerun all those tabs afterwards.
How do you rerun all the tabs afterwards?
Shift enter. Just go from shift enter again, where you're at. Shift enter. Then it'll take you to the next one. Just hit.
Oh, I got it manually here.
Keep
I
hitting
see.
shift enter and just rerun those.
There
We
we
go.
go.
Now we got stuff. Now let's
So
animate.
how did you do here? I'm gonna keep, I gotta go to the animation here.
Yeah. So now
It's
shift
not,
enter there.
where am I on the screen here? I don't know where I'm sitting
So
here.
you can, it designates it by that.
There's the blue bar.
Yeah, exactly.
Okay, so I just got a bunch. So now I should be able to. How
Yes.
did you get that to animate there? Okay, it's taking.
Okay,
its
so now
time.
you should have a GIF that's going to be created here real soon. It should show up over here somewhere.
Is that, oh, the zip or that file?
The GIF should be one of these two. I'm not sure which one. Depends on what you call it. What? Just hover over here. What is this?
That one right there?
Yeah. That's your CSV file. So what's the one underneath it? That's your GIF. So if you double click on that, it should show you your animated file there.
If you wanted to export these into eventually put in a PowerPoint or something, I'll read up on it. You know,
Yeah. So go back to
just ask ChatGPT, right?
right. So go back to your United this untitled. We can actually give it a name if you like. So now if you scroll up a little bit in here, so this function generates a plot if you give it a U and a K value, right? So this is U49.
Right.
It'll go and animate everything at this value of K, right?
Yeah, that value in time.
Exactly. And then we're just passing that as a variable, so it actually makes that look pretty. But so now if you wanted to, you can save these plots. So, and if right after, let me clear up these lines here.
Sorry, Charlie, could I just talk? So what the GIF file, it's not animating in time, it's just evolution, it's evolving it at time 49. That's not an actual evolution in time.
No, it is. So if you go back to animate, so animate, you're sending a bunch of K values.
Oh, wait, I see.
And you're passing that your array of the K values, and you're passing in that value of K, and what it does is it calls up plot heat map and then gets that particular heat map for that particular value of K.
So where has the value of K been defined though? Because this is just a function, so K has to be passed in. Where is this actually executed here?
Okay, so now inside this function, funcAnimate, so this is built in to Python. This is part of the Matplotlib module, all right? And the way
Okay.
this works is, let me get rid of, I need my mouse. There we go. All right, so the way this works, if you notice that there are, we have this plot figure. So all that does is just sets up a generic canvas, okay?
Right.
This is the function that does your animation. So this
I see above.
makes a
Okay.
function call to this guy. This is how many frames we want to calculate or we want to animate for, okay?
Right.
So we're going to animate for as many time intervals that we have. And we have max iter time as a number of intervals that we are running for, right? So the way this works is that then this sets up kind of sort of an array for frame will be equal 0, all the way up to frame equals whatever this value is, max.
Yeah. Right.
50.
Right. In increments of 1. Okay.
Yeah. So then we have f equals 1, f equals 2, so on
I
and so
see.
forth. And it passes, this is now behind the scenes, it is calling animate, and it is passing the frame number to this animate function.
Yeah.
So
Okay.
this will be k equals 1 for frame equals 1, all the way to k equals max, which is, in our case, 50.
Right. Yeah. I understand.
Yeah.
Okay.
So this is what's passing in the value of k. All we're then doing is taking that k and passing it into this plot heat map.
Right. So this false, it's either false or true. It repeat itself. The thing will just keep cycling through.
Correct. Yes. If we were to call that repeat, it would continuously generate that plot over and over and over again for us.
Until you hit
But
Control D or you fall asleep, I guess, right?
yeah, and the thing is normally if we were to run this on your local computer that's got a graphics card, we would see this plot. And if you said repeat equals true, it would just constantly repeat that plot over and over and over again on our screen. But because this is on a cloud remote system, we actually have to save it as a GIF to be able to actually visualize it.
I see.
Yeah.
Okay. These lines right here, because you're just defining a function. These lines could have appeared in a separate entity there, right? They didn't
Yeah,
have to
yeah,
appear.
it sure could have. It could have shown up on a
They could
different
appear any
cell.
place as long as you define this function. Like if you define another one up here, as long as that's defined. But okay, this return plot. I guess it's just this is probably just notation with that. Okay, I'll read up on it.
Yeah. I mean, like the biggest thing you should see is PLT defines a plot for us, right? So we created this plot, and
Right.
all
Yeah.
PLT does is just creates that canvas, and then we just draw stuff
Sorry, I
on.
didn't mean to move it for you there.
Oh yeah, and
One
so
last question. Again, I'm doing a perfection. Somehow this temperature label's not right.
yeah, so we need to put an F in front of here, in front of that colon, or I'm sorry, in front of the quotation mark.
An F?
Yes. So what F designates is this is a formatted string. So now it reads this little bit as a format. So instead of reading this as a string, so now that you have this as an F, if you hit Shift Enter here to commit it,
Yeah, it did, but
do a
it's not doing anything.
then do a Shift Enter here.
Oh, sorry.
And now you'll see it says 0 time because you passed in a 0. Technically, this and this should be the same. So if you make this a 49, it'll actually be what's happening at the 49th unit of time.
Yeah, I forget. I'll have to
This is-
study what K is the point in time, right?
Yeah,
And
exactly.
for,
Right. So
I
this
forget what the
is
bracket was for 49. 49 is the location, and what is the second 49? It's the K, the index for. What is K the index for? K is the index for time. Why does that have to
correct.
be the same?
Right, right. Now I will say this is kind of hacky, my print statement here, but this U49 is all of the U values at k equals 49. Okay?
Oh, okay, because by default you didn't define the i's and the j's, so it's going to take everything at 49.
Yeah, well, so technically this line here, because this is just shorthand for Python, technically this is 49, comma, colon, comma,
Right,
colon. Technically,
right,
that is what this is.
right,
Okay?
yes,
Now, the reason I'm saying it's a little janky, because this is just an array of numbers, right?
right,
Um, this is actually an integer. This is the integer that it just uses to print this guy. You see that? That's all we're using that for, is that k, just to make those match.
yeah, okay. Yeah, I no, appreciate your help there.
Yeah. Oh,
And
not a
and I
problem.
s- we could increase the resolution. We wanted to make this nice and pretty. I'll just have to read up on that a little
Yeah,
bit.
what you can do is you can adjust the PLT. We just kind of created a generic canvas, but what we would really
Right,
do
that's okay. Yeah, no, I
is say
thought this was
PLT is going to be, size 100 by 100, and now you increase the size of it.
right. No, I think this was good there. There's the file I have here will be saved, I guess. I don't use DesignSafe
Okay.
often enough, but this will
One
be
thing I would,
saved.
yeah, actually, unfortunately, all these need to be in the My Data folder for it to be saved. To do
Right.
that, I think, where is that at?
I created right here. I think it's right here.
Yeah. Unfortunately, where we're located at is we need to copy those files in. I'll show you how to do that really quick. So if you
How do I
click
go
on,
back up? I'm sorry.
so
How do I
that
go back?
actually, that uploads.
Oh, I know. How do I go back here?
Just click on, man, I keep losing my marker.
Click here.
Yeah, click here on that folder. There you go. Now, you can click on these and to select.
Which ones do I select?
So if you right click on it, this is your notebooks. If you right click on that, you can do a copy, and then
Is it my data you said?
tells you where you want to copy it to. There you go. Now you paste it in my data.
Okay, so
So
it's
now
pasted in.
yeah, and that's never going to go anywhere. That's going to sit in your design safe.
This was the GIF file here, so I'm
Yeah.
going to copy that. This is all this hard work. I gotta, as you say,
So
I have to
copy,
have something to show for my time here. Yeah. Okay.
then the
Sorry.
exact same.
I don't know if this is beneficial to anyone else, but um, and this right here was okay. The data file. If you don't mind, I'm just going to open this here. This should be
Yeah.
the
This-
Excel compatible file, even though it's going to. I don't know. It's probably pretty big. Sorry about that.
Oh no, it's like 117,000 lines. It's fine. It'll open it. It won't take too much time to open. There you
Okay.
go. So
Yeah.
that's
So
the
you get.
raw comma delimited file.
Yeah, so you could export this and play with whatever. I
Mhm.
think those are the three main files that we created, so I have
Yeah.
copies of those. And if I want to access my data, I just log back into DesignSafe and go to, where is this stored under in the DesignSafe?
So it's stored in, actually go back to DesignSafe real quick and I'll show you exactly where it is.
Uh,
So click on Use DesignSafe up there on the left. And go to Data Depot at the very top.
my data.
Now, if you click on My Data,
There we go.
there is
Okay.
your results, there's your GIF, and there's your IPNBY, your notebook file. We can probably rename
Yeah.
that, call it something more. All the IPNBY checkpoints that's just internal for Jupyter notebooks, so it knows where you left off and
Okay.
but the
Put it
notebook's
down.
actually inside here. I think if you double click on that or open it up, it'll show you a rendering of the notebook. You can't edit it here. You have to actually go into Jupyter to open it.
Yeah, no, I appreciate it. I guess Jupyter, I always have to log in and DesignSafe to use it, or there's other ways to do that. Like you mentioned, using it locally in my machine to
Yeah,
make
you can
plots.
download Jupyter to run locally on your local box. It's just we have it here for you on DesignSafe. It's kind
No,
of
that's fine. It's
yeah, because it
convenient.
keeps
Okay.
everything in a nice place. All your files are in the same place, all your notebooks are in the same place, and you'll never lose them.
Yeah, no, this is good, Charlie. My only comment is it's from a programming perspective for students. You know, when we were students, we had to do things the hard way. You couldn't mix integers and real, and everything had to be really structured, so you
Yeah,
knew where the bugs
Python
were.
is loosely typed. There is a data type behind the scenes. So if you like go back to your notebook and you do a type and the name of the variable, you'll see that it is a integer or it is a float or whatever. So like if you
So
do
just say
a
type.
yeah, do a type and then do an open parenthesis um, U, and it'll say U is a NumPy list. It's just shift enter there is a NumPy array. Do type plate length.
It was.
Yeah. Type instead of yeah. There you go. Yeah.
I can't. My keyboard. I'm gonna blame it on my keyboard
Yeah,
here.
I blame it on
As
that
an
one. So you
integer.
see plate length's an int. So even though we didn't type plate length as integer, Python was able to recognize that it is an integer. And then same thing like what we did with variables I or above is
Yeah.
just
So it literally in expressions, it
yeah.
can mix integers and reals, even though, when you did the old style program, you had trouble with that. It would complain, right?
Now
You had to,
I will say this. We are using Python 3, and Python 3 is pretty much the standard right now, right? Nobody uses
okay.
Python 2 anymore. Python 2 did the exact same stuff that C does. If you do integer times integer, it'll be an integer. Integer times float will, also, result in a float. All that float plus float will result in a float. So it does the integer math, floating point math in Python 2. Python 3 did away with that, and so now it's more of, oh, I see, I'm adding an integer, I should get an integer instead of integer and a float. If you multiply an integer or a float, used to give you an int, and so now it doesn't do that anymore. Now it actually does type things properly, so you don't have to think about it too far. Remember, like back in the day, integer times, if you did like 2.5 times 2.5, it'll give you an integer or a floating point as a result. If you did a int times float, you used to do all the funky integer math back in the day. Python 2 still did that. Python 3 does not. Python 3 has now adjusted. Um, so it's,
Okay. Yeah, it's a little bit more forgiving. Okay.
yes,
No, this is good. I
Python 3 is
appreciate
much more
it.
forgiving than Python 2 was.
Tutorial. So you mentioned you're gonna have a follow-up with the machine learning
Yeah,
aspects.
yeah. I've been putting that together now. If we want, Scott Brandenburg made a comment about maybe we can probably put that on the schedule for 2 weeks from today. We'll do the machine
Okay.
learning. We can analyze this data that we just created. If you notice, we only ran this out to the next to 50 time steps. Well, what if we want to go to 1,000 time steps? Well, I can do a machine learning algorithm that will be able to calculate that for me and
Yeah,
find out.
so he mentioned also vectorization, which is to optimize that. That's a separate discussion as part of the machine learning.
That's a separate
Well,
discussion, but I can probably put that into that talk as well as vectorizing this because that is something important.
I mean, because typically, like I have students that do time history analysis, and they run out to time steps of 0.005, and there's
Mhm.
2,000 or there's
Yeah,
40 seconds to be 20,000 time steps. It'd be good to be able to inform them about that.
yeah.
Okay.
And I think we'll do some error analysis as well to see how much the error is as well, and if that's an approach we can do. We'll figure it out.
Okay. Yeah, I have a student that's actually working with Bayesian neural networks, and it's interesting because there you can generate the density functions and quantify the error.
Mm.
We just start looking at these, and I think it's very interesting that maybe that's something when you show the machine learning, I could ask some more questions later then.
Sure,
Okay.
absolutely. And if we're
Okay.
not, and like I said, if Scott Brandenburg shared his repository for the what used to be part 2 of this lecture, which was speeding things up and optimizing it. So that might be a thing to look at.
Okay, I think he put this up. This was
Yeah,
that's it. Okay.
Yeah, that's exactly what part 2 of this particular talk used to be.
This is part 2 of.
This was the original part 2, which was essentially accelerating, make Python faster. Python is a great language, but it is slow in some situations. It can be
Right.
slow. There are tricks you can implement to speed it up. Or you can implement what Scott and Krishna did in that GitHub repo.
Okay, I'll take a look.
Yeah, absolutely should. If you have any questions on it, feel free to reach out. I saw that you have my email address. You can also
Yeah, no, appreciate it. Yeah, I didn't use my account for a while, so I started off to be a big pain in the butt today, but
it is. It can be a pain.
this is very useful.
I,
Okay.
I wish we could make it less painful.
No, but I understand why, because there's a security issue there, so it is worth the trouble, right?
Yeah. And like
Okay.
I
Well,
said,
anyway,
I
so
wish
yeah, thanks, Charlie.
we're trying to make it as painless as possible in some places because it's painful in other places.
No, it's okay. The pain is worth the gain here, or the gain is worth the pain, sorry.
Yeah.
Okay, well, thank you very much there, and I'll look forward to
Use
the
versus
next
fees.
webinar. I'll keep my eye out for the announcement that Natalie posts there.
Yeah, of course. Thanks so much, James. I really appreciate the questions. I'm happy we're able to get your code debugged. So.
Okay, and you did notice my jacket. I'm from Texas,
Oh, very nice. Yeah, I did see that. I thought it was a Texans jacket, but
No, it's a Longhorn jacket. No.
even that, then you've gained my respect.
Okay,
Did you go
thanks.
to UT?
Yeah, as a undergraduate and master's degree. So, and
Oh,
I
cool.
worked in Houston at Exxon, and it was it's a you much better appreciate Austin when you leave it and live elsewhere than you want to move back. So
Yeah, that's very true.
yeah,
What department were you in when you here?
it's civil engineering.
Very cool.
Over in,
Yeah, so
it's over.
you know Ellen Rathje and that crew pretty well then. Or were they before?
Yeah, I was there before she arrived
Okay.
there, but Ken Stokey was already there
Okay.
for a year or two.
Yeah.
Yeah, I
Ellen's
mean,
fantastic to work
doing
with.
like everything else.
Before Ellen's fantastic, and Krishna Kumar is in the civil engineering as well, and he's a great resource. So
Yeah, yeah, it's a good department there.
it really is a great department.
Now we're all on edge because of the administration. When I say administration, I mean at the highest level of
Yeah,
research and that stuff. We're all well on edge, but we'll hope for the best.
hoping for the best. Yeah,
Yeah.
that's what all.
Okay. Well, thank you very much. I actually was going to spend time reading up on Python, but this really accelerated the learning curve. So
Good.
now I've become dangerous.
Yeah, I think that's what happens with everybody who learns Python. Everybody becomes a little dangerous.
Yeah. Okay. Don't worry. I won't blow up the world, at least
Oh
not
no,
yet.
it's all good danger.
Yeah. Okay. No, very good, Charlie. So I'll fill out the evaluation. I think I just have to go to, I took a picture. There's a link to the evaluation there, right? The
Yeah.
survey, sorry.
Yes, sir. Yeah, there is. So a survey.
Okay.
Hopefully, let us know what you need, and we'll see what we can help you out with.
Yeah. Well, to tell you, I mean, my applications are, my students doing we do a lot of real-time cyber physical simulation. We have to use a lot of
Nice.
machine learning with neural networks, and we use Python really to execute and set up the models, the TensorFlow and all that stuff. The only problem we have is to run it in real time. We basically use Python to train the network, right? And then you transfer those weights, we put them in the Simulink, so then we execute it in real time because we have to
Oh,
use the neural network model. And it works well, but you have to run Python and TACC to train the model. So we originally back up, we would use OpenSeas to generate the training data, right? And there's a lot of files there. Then you use Python to develop and train the model and go through the verification. Once you have what you think is a good model and the weights, et cetera, then we'll take that and we're putting it in a paper, we then import that into Simulink. We create the network in Simulink that when you compile Simulink, it creates real-time code that you can then execute on a real-time operating system, which is what we do in order to do cyber physical simulation real time, because we're interested in modeling the soil underneath a structure, and that soil, if you did the conventional fine element method, would be prohibitively and computationally intense. You couldn't do all the calculations in real time. And so we replace that with a trained neural network. And with a trained neural network, that becomes a subdomain of the foundation of soil, which we put then the fine element model on top, which that part we can in real time. We have then a physical part like dampers that we all connect and link all together. And we, have gotten all that to work. I presented this to Tim at the symposium you guys had there last month, was it? So
Yeah.
then
Yeah.
we're going to work a little bit more with you guys on that. So the latest thing is uncertainty of quantification. And to do that, there's uncertainty in the weights and the bias and all that stuff. That's why we're getting into the Bayesian neural networking, because you're using a neural networking, how good does it affect the result in the end? You're trying to look at performance evaluation. And so if you want to judge what is the 95 confidence interval on your results that you say you're looking at a performance, you have to trace it all the way back to the neural network. So that's where we have to look at the Bayesian neural networks and kind of vary. So what we've done there is to create 100 networks where we take the Bayesian network and then you basically could generate 100 networks from that, and we run those and get histograms on then the simulations to get an idea of the effect it has on the end result. It's
Cool.
very hard to quantify and use that. I forget what you call it, but that quantification, which you take derivatives, go all the way back. You could do that in FEM models, but with neural networks and some of the layers, it becomes very difficult, to take derivatives working back through the neural network. So we just use the Bayesian neural network, and it's kind of like a Monte Carlo approach, but I think it'd be good to compare it sometime.
Yeah. Yeah. So, I mean, something else we're putting together as well, and this might be useful to you, is a kind of a broad stroke of all of the popular AI ML algorithms out there, what they do, how they do it, and I would love to be able to do all those against the same data set to see how they compare. But it'd be interesting to play with. Yeah, there's a lot of stuff out there. Usually just a standard CNN is what I normally work with. But there's so many other cool things that I'm learning and playing with. That's like,
Yeah,
oh, I can't wait to.
we've used the LSTM with data augmentation and regularization. And when I'm saying that, we will train a network. You have your complete model, you're getting the data, then you train in the neural network. It's open loop. That is input and output. You train it, right?
Right.
The problem that we face is we take that trained model and we connect it to a system, and that system feeds back into the network. So it becomes a closed loop. So any
Very
noise or
cool.
something generates up here, it comes back, or any slight perturbation of the system here for what it's been trained for, it gets thrown way off. So what we do there is we do data regularization, which we perturbate, say, the OpenSeas model to some extent to try to look at that during the simulation. But then we also do regularization, which I think Gaussian was called Gaussian dropout works the best. And it really cleans things up because it becomes closed loop. And if it's open loop, you never have that problem. But depending on also how you use neural network, in our case, it's totally coupled. If you use a neural network in which it's just for the loading, applying it to a system, that's not closed loop because the loading would just excite the system, but
I
the
see.
integration of the equations is all closed loop. But it's when it's coupled with the integration schemes and becomes closed loop, that's where it presents another challenge. Yeah.
Cool.
I eventually I could send you copies of some papers. We had the algorithms printed and published, but it's still under review. But I'll send you a copy as soon as it's approved here. That
Oh, I'd love to check it out and take a look. That'd be cool.
yeah. So I realized going to your symposium, I should work at least get more acquainted with what you do, and even volunteer to be on some of the whatever opportunities are the committees. I think there's now a lot of synergy that could be done. I think particularly things Sim Center and the sites, because we're getting the heavy computations, but trying to tie that with cyber physical. So without the heavy computations, we can't do the other end. And it's gotten to the point that we need to rely on high performance computing and some of the tools you guys have. So I'll have to keep in touch there.
Awesome. Yeah, definitely do. So
Okay. Anyway, so it was good talking to you, Charlie. Again, I appreciate it quite a bit. This was very useful, at least to
good.
me. So definitely gonna make use of it.
Thank you. Appreciate it. Yeah, and
Okay.
keep an eye out on the DesignSafe channels in the news and the emails. We'll get that next webinar scheduled. And
Okay.
so,
Okay. Sounds
hey,
good. Okay.
it was great meeting you, James.
Yeah. Thank you. It's nice
When
to
you're at TACC
see
next
you.
time, let me know, and yeah, definitely talk to you a little deeper about this. So,
Okay. Okay. Sounds good. If I'm in Austin, I'll give you guys a call ahead of time.
oh, definitely do. Come on by.
Okay. Thanks a
Right.
lot, everyone.
Thanks, everyone.
Thanks, everybody. Yeah. Bye.
Y'all have a great afternoon. Thank you so much.
You too. Thank you. Bye.
Thanks, everyone.